Hello, my name is Patrick Thrauzabule. I will be doing this for my mock course for the Berkeley Music Introduction to Audio Production, and this one is signal flow using your home studio, your home equipment. Okay, so when we talk about signal flow, generally what we're talking about is how do we get our instruments, our voice into the computer, how does it get interpreted, and how does it get spit back out. So the first thing we're going to do is take a look at this mic. This mic is an audio transducer, and what that just means is that it is taking the audio that's and transducing it into an audio signal. How it does that actually is interesting. What it does is, if we were to take this metal grating off, we would see that inside this microphone there is a bladder. The bladder looks a lot like a speaker, and it acts a lot like a speaker. If you've ever taken a speaker apart, what you'll see is the bladder is attached to a spring, and the spring is connected to wires. Either inside the spring or outside the spring, rubbing against that spring is a magnet, and that magnet helps to create an electrical signal. So when I speak, I am creating pressure in the air, and that pressure gets felt by that bladder. The bladder depresses and recesses, and when it does that, it's rubbing it up against that magnet, and with the spring connected to wires, it's creating an electrical signal that changes with the depression of the speaker. Well, those changes in how strong the bladder depresses and goes back again, that's your audio signal. It's just electrical voltage. Now, generally, that electrical voltage would have to be sent into something like this, which is a very old school audio interface. This audio interface doesn't work anymore because there are no drivers that work for it outside of Windows 98. So I don't use it anymore. I just keep it around and feel nostalgic about it. But generally, that's what you would want. You would want the signal coming from your microphone into your audio interface. The interface usually has some type of power in it that will boost the audio signal and get it up to line level. Okay. Once it's up to line level, it will do what's called a digital to audio conversion, meaning that it will just take samples of the peaks and valleys of the sound and represent them as ones and zeros, something that your computer can use. Well, that's all well and good. How am I getting sound into my computer right now? Well, this microphone itself is a USB microphone, which basically means it's a sound card all on its own. It has a digital audio converter inside it already. So it already does the conversion and the phantom power and everything else it needs to get that signal up to line level, and then go ahead and do a digital to audio conversion. That digital audio conversion takes place and goes along this USB cable into a USB port in my computer, and my digital audio workstation will then go ahead and make a representation of the sound from the samples it's taken, audio converter. And now what we see here is actually a part of my DAW. It's a part of FL Studio called Edison. It's the main audio editor where you'll do most of your chunks and of editing and cutting and splicing and things of that nature. Things that you might want to do destructive editing of. Here we are, and you can see it's recording my voice here from my microphone. There's my microphone, and it is recording my voice. Now, the good thing about this situation is it's just taking it in from the DAC inside the well, the DAC is sending the zeros and ones, the digital code, to this application, and this application is recording that information and being represented here on this timeline. And it's simply a sample of the sounds I'm making throughout this recording. So we can see that that's being done. We understand that's being done. Let's go ahead and stop this recording. Okay, and so now that we have this recording, what can the machine do with it? And that's the important thing to know there. Let's go ahead and disconnect it from the rest of from my speakers here, so I can turn it up and we can hear it. Okay, so if I go and I tell the mic to disconnect from Edison, there. Alright, so now with this being a digital signal, what's going to happen? Well, if I play this, okay, well, you can hear it. Why can you hear it? Well, the digital signal is being fed to an actual audio to digital converter. And if we take a look here, we can see that Edison is sending its audio signal to the system. And what's connected to the system? Well, what's connected to the system here is, for the output, is my Behringer Xenix mixer. And my Xenix mixer here is connected to these monitors. And all that's happening here is that this information is being taken from my my software Edison and being sent to a Behringer USB mixer. That information is getting sent as to its internal A to D converter. It converts the zeros and ones back to voltage, and that voltage is sent to the speaker, and the speaker is just like the microphone, working only in reverse and much bigger, needing a bigger voltage, needing amplification, things of that nature. But it is an exact replication of the information that went into the mic and was recorded into the software, and is now hello. All right. Okay. And is now coming across the speaker, coming out of the speaker, and that's how the signal workflow is. So that's how I record music. Thank you. Bye bye.